we have a question on the wave function. We have to express 5 cosine x minus 2 sine x in the form k cosine x minus a. K must be positive and a must be between 0 and 2 pi. So we're working in radians. So pause this and have a go if you wish, but I'm going to continue. So the first thing we want to look at is, well, we can start with the cosine of x minus a. And if we have a look at a past paper, this is on page 2 of the exam book. It's the formula sheet, and you're given this format. You're also given this one. Well, we have cosine x minus a, so we notice we can start by, instead of writing a and b, use small x and small a. So let's start this. Cosine x cosine a, and we have negative on the bottom, but there's a plus on the bottom. So cos x minus a means we have to put a positive, and it's going to be sine x sine a, lowercase x and a. But we have to use k cosine x minus a. So let's multiply both of these expressions by k, and let's expand the bracket on this. K cosine x cosine a. In fact, I'm going to write cosine a first. I will show you why I've done that in a second. And we have to compare this with 5 cosine x. Minus 2 sine x. So you'll notice if we compare these equations, you've got cosine x and cosine x. So k cosine of a, let's mark this in green, is being multiplied by cosine x in the first one and 5 in the second. But we also have sin x and sin x, meaning that we've got k sine a being multiplied by sin x, and we've got minus 2. So essentially that's 5 cosine x plus minus 2 sine x. So we then have k cosine a is 5 and k sine A is -2. Suppose we squared each of these, and something really smart is about to happen. So if I square this, you get k squared cos squared A, and that's 25. And we get k squared sine squared A is 4. But if I add these together, then I can take a common factor of k squared, and in the brackets we get cos squared A plus sine squared A. And cos squared A plus sine squared A is 1. So that is k squared. And we get that by adding these two, so that's 29. But we're then told that k has to be positive, so it's going to be the square root of 29. And as k is greater than 0, we can just take the positive. And we figured out k. The next part we have to then figure out is the value of A. Now we have k cosine. I've got k sine of A and k cosine of A. The k's cancel out, and we're then left with the tan of A. So k sine A is -2, and k cosine A is 5. So that's the value of the tan of the angle. We now want to look at what's called the cast diagram, and essentially it dictates which coordinates the sine, the cosine, and the tan are positive. So in the A quadrant, the sine, the cosine, and the tan are all positive. So if it's positive, it will be in red. If it's negative, I will put it in green. So the cosine and the tan, the sine and the cosine, the sine and the tan, those are the negative ones. The sine, the tan, and the cosine are positive. So we have the tan is negative. So it can't be the first quadrant because the tan is positive. It also can't be the third quadrant, the t quadrant, because the tan is positive in this quadrant, but it's negative that we have to find. K sine A is negative and K cosine of A is positive. Now, because K itself is positive, then the sine of A must be negative. So the sine must be negative and the cosine must be positive. So it must be this one and it can't be this one. So it's this one we have to work with. And what we then do is we want to find the inverse tan of 2/5. And we're working in radians in this question, so let's do the positive 2/5. So you don't put minus 2/5 into the calculator. You take the positive value and you then plug that in and you get 0.380506 radians. So you never put in the negative. You make sure you have the positive of this number here, of the minus 2/5, and you then choose the correct quadrant. So the quadrants work like this. We'll call this angle, I don't know, B. Suppose we call this angle B. Well, this quadrant will be B. This one is pi minus B. This one is pi plus B. And this one is 2 pi minus B. Because we've identified this one, the angle A is going to be 2 pi minus 0.380506, and plugging this into the calculator gives you 5.902679 radians. And I'm going to round this to 4 significant figures. We're not told about any rounding that we have to do, so we have the value of A and we have the value of K. So let's write it in the form we require. So K is root 29 and cosine x minus the value of A is 5.903 and we have finished. So I hope you found this video useful, and once again, thank you for watching.